Hi, Assalamualaikum. Today we are going to learn about the complex number. Have you ever tried to solve these equations? Suppose we have x squared equal to -1. So we try to solve by having the square root on both sides. We have square root of -1 on the right side. Can we solve actually the square root of -1? Before this, because we were just dealing with the real number system, then we could not solve this equation. But now, when we consider this as a complex number, we can actually solve this one, because in the complex number, we have the rules that I squared, which is equal to -1, and I is actually square root of -1. So how can we represent this complex number in this complex number plane, right? A complex plane, right? So usually, right, so before we go far, usually we represent the complex number with a plus bi. So z equal to a plus bi is actually a complex number, right? So a plus bi, z is equal to a plus bi is a complex number. So now I want to represent this on the what do we call this complex plane. So a here is actually the real of z, and b here is actually the imaginary part of z, right? So we have in the complex number z, we have the real part and also the imaginary part. A is the real part and b is the imaginary part. All right, so when we want to represent this on this complex plane, so we have on the real plane, all right, so on the real part, say it's actually real z, so we have that a here. Suppose we have that a, it's here, and we have b at the imaginary part, so b here, so that is the point a b. All right, so this is the complex plane, the coordinate on the complex plane. So we have that line is actually the z, which is a plus bi. All right, okay, now that's basically a complex number. All right, all right, let's see some so for example, right, so we have so many types of complex numbers, so many forms of complex numbers. Suppose we have z equal to 1 plus 2i is a complex number. This is an example. Suppose we have -1 minus 3i, also a complex number. Is z equal to 4i is a complex number? Yes, because this is actually 0 plus 4i. The real part is 0 and the imaginary part will be 4. And suppose we have z equal to 3. This is actually a real number, right? So a real number is actually 3 plus 0i. So a real number is actually a complex number, because in the first video that we have learned before this, we have the biggest set, which is a complex number, and inside this complex number is a real number. That's why we say that z equal to 3, which is a real number, is also a complex number, because R is the subset of C. Okay, now we need to see some operations involving the complex number. Suppose we want to see the addition and also subtraction. So we have the addition, which is given by this formula. Right, suppose we have two complex numbers, a plus bi plus the c plus di. Now we need to add the, what do we call, the real part first. So we have a plus c, and now we are going to add the imaginary part, which is bi plus di. So we have plus b plus di. All right, so this is what we get when we add two complex numbers. Right, now we want to subtract. All right, now we want to subtract, so meaning to say that we a minus c. All right, so we'll have a minus c, we plus with the part where bi minus di. So we have something like b minus di outside. All right, okay, so we have something like this. For example, suppose we have 1 plus 2i, all right, plus with -3 minus 4i, for example. So if we add this, we'll have something like 1 minus 3 plus with 2 plus -4. So we have 2 minus 4i. So we simplify this, we'll get -2 minus 2i. All right, so the addition of the two complex numbers will give you this one. All right, now What if we have the multiplication between two complex numbers? So we need to find the multiplication between the two complex numbers, a plus bi and c plus di. So we multiply, all right, a c, so we'll have a c. Now a plus a di, all right, plus a di. Now we have bci plus bci, and we have bdi square plus bdi square. Please recall that I square is actually equal to, we know that I square is actually equal to -1. Therefore, we can substitute that I square with -1. So we have this one as, okay, this one as -1. Now we have this one, all right, simplify AC plus, all right, now I want to factorize AD plus BC. I put in a bracket, I outside, that one will become minus BD. So we know that BD and also AC are the real parts, so we can put them together. So we'll have something like, all right, AC minus BD plus with the AD plus BCI. So now we have the real part, which is here, and this one is the imaginary part of this product of two complex numbers. All right, now, let's now look at the concept of the magnitude for the complex number. So basically, suppose we have a plus bi on this complex plane, right? So this is the real part of z, and this is the imaginary part of z, and we have, suppose, and a plus bi. All right, so this is a plus bi, and we know that this is actually given by a, and this is actually given by the ordinate, all right, somewhere on there, which is b. And we know that if the length here, all right, it should be given by b, and the length here should be given by a. All right, and if we want to find the length here, which is from this to this, all right, so we have to use the Pythagoras theorem, because we have this triangle which is given by b and a here. So of course here is actually the square root of a square plus b square using Pythagoras theorem, because this is the hypotenuse. So this is actually the magnitude of the complex number. So magnitude is actually the length of this hypotenuse. So this is given by a square plus b square. All right, now suppose we have this 1 plus 3i. We want to find its magnitude, therefore we just need to find it, the square root of 1 square plus with 3 square. So this is actually 1 square plus 1 plus 9, which is 10, square root of 10. Right, this one, square root of 2 square plus with -1 square. So this is given by square root of 5. All right, for 4i, right, we don't have the real part, which is 0 square plus with 4 square. So in this case, it's actually 4. All right, so the length is 4. So this is the magnitude. All right, so easy. Now if we have this, we want to solve, all right, now we want to solve the complex number equation now. All right, suppose we have x squared plus 4, which is equal to 0. So how to solve this one? All right, actually we should start with, all right, so x squared equal to a -4. So we want to remove that square, so we'll have to take this square root. So recall that when we take the square root, it should be a plus minus. So there should be a plus minus here, right? But we have the square root of -4. This has no solution in real number system, but we have the solutions in the complex number system. Recall that we have I square, which is equal to -1. Therefore, I is actually a square root of a -1. Now we want to break out this square root of -4 into what do we call square root of -4 means square root of a -4. Square root of 4, right, multiply with a -1. All right, now we can have this one as, all right, a positive part. Let me consider the positive part first. So this is 4 square root of a -1 comma, we have a negative part which is given by negative square root of 4 multiplied with a square root of negative 1. So we know that square root of negative 1 is given by I, alright? So we have this one as x. Square root of 4 is actually 2, so 2i, and this one should be a negative of 2i. So we have two solutions for this quadratic equation actually, alright? When will you know that you have to find you will have these solutions in a complex number, right? So let's just recall the quadratic equation. So where we have the quadratic equations, we have the formula which is given by x, which is negative b plus minus square root of b square minus 4ac. We divide with 2a, right? Now we have this part. When we consider this part, so when we have the first case where b square minus 4ac, which is equal to 0, then our solution will have, alright, only one root, or only one value of x. Actually there are two values, but they are the same value, alright? So we consider it as one root only. And the second case, we have b square minus 4ac, which is greater than 0. Then we will have two different roots, or sometimes called two distinct roots. Alright, so we'll have two different answers for x. Right, but for the third case, alright, before this, when you were in the secondary school, you learn less than 0, you say that there is no solution, right? You say no solution for this one, because when you press your calculator, or your calculator at the top there will show RI. This is actually real imaginary, right? So this has a solution now, because we are considering the complex number system. So this has a complex root. Alright, a complex roots means that the value of x are in complex number. These are the complex roots. Okay, alright. Now, let's find this one. Alright, let's try this one. So let's just first recall this. Let's check this one. If b square minus 4ac is equal to 0, or greater than 0, or less than 0, so b square b, alright, so this is a is actually 1, which is the coefficient of x squared. B is actually a negative 4, which is the coefficient of x, and c is the constant here. C is 5. And we have b, which is a negative 4 square minus 4ac. A is 1 and c is 5. We'll have 16 minus 20. This is actually a negative 4. A negative 4, which is less than 0. We have the case where b square minus 4ac is less than 0. Sorry, b square minus 4ac is less than 0. Therefore, this we will have a complex root. Alright, complex root. Now, we have to solve this using the formula for the quadratic, which is given by a negative b plus minus square root of b square minus 4ac divided by 2a. Right, now we want to substitute the values inside this formula. So a negative 4 plus minus a square root of b square minus 4ac, which is a negative 4 square minus 4 multiplied by 1 multiplied with 5, divided by 2a, 2 multiplied with 1. So we simplify this one. We will have something like a positive 4 plus minus square root of negative 4 divided by 2. Alright, now I want to break this into two parts because we have a plus minus here. So first case, we consider the positive part, which is plus of square root of negative 4 divided by 2. In the second case, we'll have a 4 and minus a square root of negative 4 divided by 2. Alright, now we have the square root of negative 4, so we want to break out this into square root of negative 1 multiplied with 4, right? So this one will have something like 4 plus with square root of 4 square root of a negative 1, right, divided by 2. And this one will have 4 minus square root of 4 square root of negative 1 divided by 2. Right, now we simplify this. Well, we have something like 2i, because recall that square root of negative 1 will be I. Right, so this is actually divided by 2. Okay, here. Right, we have this one as 4 minus 2i divided by 2. Right now you have to divide with 2, therefore you'll have 2 plus I, and this one is actually 2 minus I. So we have two solutions here, right? And these solutions of x are in the complex number. We have complex roots. Now let's consider this example. Suppose we have for a is given by this complex number, b is given by this complex number. We have to find for a plus b. So it's easy, right? So for a plus b means 4 multiplied with a, 4 minus 3i, plus with b, b is actually 1 minus 7i. And then you expand 4, you get you expand 4, you get 16 minus 12i, plus 1 minus 7i. I collect those real parts, which is 16 with 1, you get 17, minus 12i minus 7i, you get minus 19i. Alright, so you have 4a plus b is given by this complex number. Right now you want to find a squared plus a minus b, but we don't have a minus b. Now we can find the value for a minus b. Suppose we have a minus b, which is given by 4 minus 3i minus the part where 1 minus 7i. We simplify this one, we'll get negative, alright, minus 1 plus 7i. Therefore we have 4 minus 1, which is 3, minus 7 minus 3 plus 7, we get plus 4i. Right now we have a minus b. Now what is meant by a square? A square means we multiply a twice, so 4 minus 3i, 4 minus 3i, plus with the magnitude of a minus b, which is given by a minus b, which is given here. Alright, so we put in here, right? So the magnitude of 3 plus 4i. Alright, now we have this one will be, alright, 4 minus 4 multiplied with 4, 16, minus 12i, minus with 12i, plus 9i square. Right, this one will be square root of 3 square plus 4 square. Alright, so that one is actually 25. Square root of 25 will be a 5. So 16 minus 24i plus, alright, plus 9i square. Now I'm converting this I square, which is a negative 1, therefore this number will become minus 9. Right, plus with square root of 25 will be 5. Alright, so we collect those real parts. So 16 plus with what do we call 5 will be 21. 21 minus 9 will be 12. So 12 minus 24i is the final answer. Right. Alright, sorry. Now let's move to the concept of the conjugate of the complex number. Suppose we have z, which is given by a plus bi. So the conjugate will be labeled by z bar here. So we need to find the a plus bi. We have the bar. All right, so this is actually given by a minus bi. Right, for example, suppose we have z equal to 2 plus 7i. So what about this one? If we want to find the conjugate, so this one will be, we just need to change the symbol for the imaginary part. So 2 minus 7i. This one, z bar, will be, right, so this is the symbol for the imaginary part. So this one will be 3 plus 5i. What about this one? What about this one? Okay, so that is the imaginary part, right? So we'll have z bar will be, because that one is positive 7, so we'll have negative 7i. What about this one? Z bar. Do we have the imaginary part here? We don't have, because this is a real part, so it doesn't change. So that one will be negative 3. All right, maintain as, remain as negative 3 is the z bar. Okay, now there are some properties of the conjugate. All right, so z bar. All right, so suppose we have z, which is given by a plus bi. So of course our z bar will be a minus bi. If we want to find the multiplication between z and z bar, what will happen? So suppose we find the a plus bi, a minus bi. So we try to simplify this one, right? So we have a square minus abi plus with abi, ab, yes, abi. Okay, all right. And finally we have b multiplied with b, so we have negative b square I square. So if we analyze this, negative ABI plus with ABI will be cancelled out. So we are left with the A square minus B square. So now we have this, what we call I square is actually negative 1. So we have that part will be negative 1. So negative 1 with this negative, so it will become a positive. Therefore, we should know that Z bar will be A square plus with B square. Why it become plus? Because this negative with negative. Okay, now what if we have the Z bar bar? Okay, now firstly, suppose we have alright, so Z bar bar. So this is Z bar. So A minus BI is the Z bar, but we take the bar on that Z bar. Alright, so we'll have this one. So again, we know that when we have the bar, we have to find the conjugate of this complex number, meaning to say that we have to change the symbol for the imaginary part. So we'll have A plus BI. So we should know that Z bar bar, alright, will become a Z. It will change to its initial number. Alright, and we can actually try to prove that Z plus W bar is actually equal to Z bar plus W bar. You can try to show this, and this one also Z bar W bar. Okay, so we have something like this. Alright, now that is the properties of the conjugate. So let's try to solve some examples involving the conjugate. Suppose we have this complex number. We have to write this in the standard form, meaning to say that we have to write in the A plus BI. So we have 1 plus 3i minus 1 over 1 plus 3i. Alright, when it involves the fraction for the complex number, what we need to do is actually to find its conjugate, to multiply with its conjugate here. So what is the conjugate of 1 plus 3i? Of course, 1 minus 3i. So 1 minus 3i. Recall that if we have Z multiply with Z bar, we will have A square plus B square, meaning to say that we square both the complex part and the real part of the complex numbers. So we add them together. Right, so now okay, this one will be 1 plus 3i minus, right, so this one multiply at the numerator, we just multiply 1 with 1 minus 3i. On the denominator, we will have, alright, we know that this property A square plus B square, so we just need to square 1 square plus with negative 3 square. Alright, so we'll have something like 1 plus 3i minus 1 minus 3i over 3 square, which is 9 plus 1, which is 10. So now I bring it this way. So 1 plus 3i minus 1 over 10, right, plus with 3i over 10. So we have to add the real part together with the real part and the imaginary part with the imaginary part. I'm sorry, this is the imaginary part with the imaginary part. So let's try to solve this. So 1 minus 1 over 10, meaning to say we get 9 over 10, and 3 plus 3 over 10. So of course we get 33 over 10i. So this is our final answer for this a subtraction between these two complex numbers in the standard form, where this is A and this is B. So A plus BI. Alright, now let's go to this one. Suppose we need to write this what do we call complex number in the standard form A plus BI. So how to solve this one? So firstly, we know that we have to find the conjugate of the denominator when it involves the fraction for the complex number. So we know that when we have 1 minus I, so its conjugate will be 1 plus I. We'll change the symbol for the imaginary part. Therefore, we have that 2 plus I. Alright, so this is Z. 1 minus I, we just need to multiply with the conjugate of the denominator. So 1 plus I, 1 plus I. The intention is to remove the denominator part, right? To make the denominator part a real number now. So the numerator, we just need to multiply between the two, right? Complex number. So you'll have 2 multiply with 1, we'll get 2 plus 2i plus I square. Plus I square will be negative 1. Divided with, right, the part at the denominator, we know that z bar is always equal to a square plus b square. Therefore, we'll have 1 square plus negative 1 square. Therefore, this one will be 2 minus 1 will be 1 plus 3i divided by 2. And this one will be half plus with 3 over 2i. Yes, 3 over 2i. So this is what we have in the standard form of z. Now, we need to find the z bar z. So z bar z is actually z bar, right? So z bar z, alright, so z bar z, meaning to say that, right, we know that this is a and this is b. So you just need to find the a square plus b square. So you just need to plug it into this formula. So you'll have 1 over 2 square plus with the 3 over 2 square, right? So we have that 1 over 4 plus 9 over 4. So this will be 10 over 4. So 10 over 4 will be given by 5 over 2 or 2.5. So that is a real number, all right? A number, right? Also a complex number, right? So we get 5 over 2 is the constant there. All right, now let's go to example 6. Suppose we have this what do we call complex number. We have to write z square over this one. Okay, so how to write this in the standard form? So let's try. Z square meaning to say that 1 plus 2i multiply with 1 plus 2i divided with 3 minus of z means 3 minus 1 plus 2i. Okay, let's try this one. So this is actually z square over 3 minus z. So this is equal to this. Right now we want to multiply the numerator. So 1 with 1, 1 plus 2i plus 2i, right? Now 2i multiply with 2i we get 4i square, meaning that we have minus 4. Okay, divided with, all right, 3 minus 1 minus 2i. Okay, now we simplify this one. So 1 minus 4 will be negative 3 plus 4i divided with 2 minus 2i. Right, so is this in the standard form a plus bi? No. So we have to multiply with the conjugate. Always when we have the fraction with the denominator is a complex number, we have to convert this into a real number where we have to multiply with the conjugate. So the conjugate for this one will be 2 plus 2i, 2 plus 2i. All right, now we need to multiply this one, right? So negative 3 with 2 will be a negative 6. Negative 3 with 2i will be minus 6i. Next, 4i with 2 will give you positive 4i, and 4i with 2i will give you an 8i square. So 8i square meaning that minus 8 divided with, all right, so this one we know that z bar will be equal to a square plus b square. This is a and this is b, therefore we just need to find it 2 square plus 2 square. All right, now we simplify the numerator. So negative 6 minus 8, meaning to say that we collect those real numbers, the real part. So negative 6 minus 8 will be negative 14. We have negative 6i plus 4i will give you negative 2i. You divide with 4 plus 4, which is 8. All right, simplify this one. Negative 14 divided by 8 minus 2 over 8i. So you can what do you call, simplify this fraction will give you negative 7 over 4 minus 1 over 4i. Okay, we have something like this. All right, we are done. Now let's go to the concept of powers of I. If I to the power of 1 will give you I to the power of 2, we know that it is negative 1. I to the power of 3 is actually I square multiplied with I. Alright, I square is negative 1, I is I. So negative 1 multiplied with I, this is actually negative I. And I to the power of 4, which is given by I to the power of 2 multiplied with I to the power of 2. So this is actually negative 1 multiplied with negative 1. So this is right, will give you a positive 1. Positive 1. What if we have I to the power of 5? I to the power of 5 will be given by I to the power of 4 multiplied with I. I to the power of 4 is actually 1. Therefore, 1 multiplied with I. Therefore, we have I. What about I to the power of 6? So, of course, we have I to the power of 4 multiplied with the I to the power of 2. I to the power of 4 is actually 1. I to the power of 2, which is negative 1, right? Negative 1. So this is actually negative 1. I to the power of 7 will give you I to the power of 4 with I to the power of 3. So I to the power of 4 is actually 1. I to the power of 3 is actually negative I. So this is actually negative I. And if you have I to the power of 8, this is actually I to the power of 4 multiplied with I to the power of 4. I to the power of 4 is actually 1, and I to the power of 4 is just 1. 1 multiplied with 1 will give you 1. If you see this pattern, if you proceed with I to the power of 9, so it will give you I, right? I to the power of 10 will give you negative 1. I to the power of 11 will give you negative I, and I to the power of 12 is actually equal to 1. And you can proceed until I to the power of 100, I to the power of 1000, and so on, right? So you can solve those equations, those complex numbers involving the powers of I with higher powers. All right. Now, suppose we are given with this. All right. So we have this one. We need to find I. All right. So Z multiplied with W. Firstly, we have to simplify W. All right. We know that I to the power of 4 is actually 1, right? I to the power of 4, 1, right? Now I'm going to write W in a simplified form. So I have something like 6, right? I to the power of 7, I break it up into I to the power of 4, I to the power of 2, I to the power of 1, right? So it will become 7, right? Okay. Now this is actually 6, I to the power of 4 is actually 1, I to the power of 2 which is negative 1, I which is I. So this is actually negative 6I. W is actually negative 6I. And we know that at the denominator we want to find the ZW. So ZW meaning to say that we just need to multiply 3 minus I with negative 6I. So you multiply this inside here. So we'll have negative 18I plus with 6I square, but I square is actually negative 1, so 18I minus 6, or we usually write the real part first, so negative 6 minus 18I. So that is a ZW. Now we want to write this, we want to solve this one, we want to find I over ZW. So you put I at the numerator, ZW which is negative 6 minus 18I. Right, negative 6 minus 18I. So what we need to do when we have the fraction involving the complex number, always we have to multiply with the conjugate. So multiply with the conjugate here. Remember, the conjugate will be changed. All right, the conjugate, in the conjugate the symbol for the complex part only that is changed. So we have to multiply with negative 6 plus with 18I. All right, negative 6 plus with negative 18I. All right. Now we know that z bar will give you a square. Sorry, z bar, z bar. All right, will give you a square plus b square. All right. So this one multiply here. All right, something like this. So I'll have negative 6I plus with 18I square. Divide with 18I square. Divide with negative 6 square plus with 18 square, and you need to simplify this one. Okay, now we have that. Okay, and negative 6I square, you should know that I square is actually a negative 1, therefore this is actually minus 18. You divide with, all right, so 36 plus with 18 square, which is actually 360. All right, 18. Okay, so now you simplify this one, will give you a negative 6 All right, usually we write the complex, the real part first. So over 360 minus 6 over 360 I, and you can simplify this using, you know, okay, divided by 6 on both. So we get negative 3 over 60 minus 1. Yes, divided by 6. This one will give you 1 over 60 I. And this 3 with 60 can still be simplified. It will become, all right, negative 1 over 20 minus 1 over 60 I. Right now we are done with this one. Now, last example. Suppose we have this Z, which is a real, the complex number. Now we have to write the expression, this one. So I to the power of 19. All right, so we want to simplify I to the power of 19. So I to the power of 19 is actually given by I to the power of 4, I to the power of 4, or you can write I to the power of 4, you know, 4 times. Okay, I to the power of 4 times, because the one will be I to the power of 16, so I to the power of 3. Right now, this one, right, because we know that I to the power of 4 is actually a positive 1, right? I to the power of 4 negative positive 1, so 1 to the power of 4 multiplied by I to the power of 2 multiplied with I, so 1 multiplied with I to the power of 2, which is a negative 1, so that one is I, so this is actually a negative I. Bear in mind that I to the power of 90 is actually negative I. Alright, now we have that I to the power of 19z, so this is actually a negative I multiplied with z, which is square root of negative of square root 2 plus with 2I. Right, you multiply this negative I inside, therefore we'll have something like square root of 2I minus of 2I square. That I square will become a negative 1, so 2I plus with 2, right? Because I square is a negative 1, the one will become plus. So this one will be 2 plus square root of 2I. Okay, 2 plus square root of 2I. Now, we need to write, right? So 1 over I to the power of 19z. So we already have the I to the power of 19z, which is given by 2 plus square root of 2I. Now, always recall that if you have a complex number at the denominator, you have to multiply with the conjugate. Therefore, the conjugate will be 2 minus square root of 2I. Right? Recall this, that this should be, right, multiplied with the conjugate. So 2 minus square root of 2I. Now, we have, all right, 2 minus square root of 2I divided by 2 square plus with the square root of 2 square. Okay, now we simplify this one, it will become 2 minus square root 2I divided by, all right, 2 square is actually 4, 4 plus 2, right? Because square root of 2 square will become 2, so 4 plus 2, which is 6. So this one will be solved as 2 over 6 minus square root of 2I over 6. So this can be simplified as 1 over 3 minus square root of 2 over 6I. And we are done with this one. So that's it for a complex number. I have to get the idea how to solve these complex numbers questions. So that's it. Thank you for watching this video.